Beyond the glittering spiral arms of Andromeda lies something invisible, colossal, an ancient and unseen shroud that may decide the fate of galaxies, including our own. Tonight, we peel back the cosmic veil. Chapter 1. The Forgotten Crown of Andromeda. Imagine looking up at the night sky. Among the countless pinpoints of light, one faint blur hides a truth larger than imagination. That blur is the Andromeda galaxy. To the naked eye, it seems like nothing more than a small cloud. But in reality, it is the most massive galaxy in our local group, holding 1 trillion stars, each one a sun with its own story. Yet even this description is incomplete, because what we see, the spiral of glowing arms, is only the surface. Around Andromeda lies something far greater, something we can't see with human eyes. A halo, a vast, ghostly crown that stretches far beyond the galaxy's visible edge. It is not made of bright stars that dazzle in the telescope. Instead, it is a realm of scattered ancient stars, of thin streams of gas, and above all, of a mysterious ingredient that dominates the universe: dark matter. This halo is not just decoration. It is Andromeda's true body, its hidden structure. Without it, the galaxy could not even exist. The halo holds Andromeda together, binding its stars into place, preventing the entire spiral from flying apart. But unlike the glowing disk, this invisible crown reaches so far that if we could see it, Andromeda would appear 3 times larger than the moon in our sky. Think about that. Every time you step outside at night, Andromeda is up there, faint and small. But in reality, its unseen halo is already touching the edges of our own Milky Way's halo. Our galaxies are not waiting to collide billions of years from now. In a silent, invisible way, they are already connected. The discovery of a hidden world. Astronomers once believed Andromeda was just a patch of light, a nebula inside the Milky Way. It wasn't until the 1920s that Edwin Hubble proved it was an entire galaxy, far beyond our own. But even then, only the central spiral was known. The idea of a halo came later, as telescopes grew sharper and space observatories opened new windows. When scientists looked carefully at the faint outskirts of Andromeda, they found something astonishing. The stars didn't end where the spiral arms faded. Instead, lone stars stretched outward, sparse but real, like grains of sand scattered across a dark sea. The deeper astronomers searched, the more they realized these outskirts weren't empty. They were part of a giant envelope, the galactic halo. Andromeda's halo is not a thin shell. It is a vast sphere, surrounding the galaxy on all sides, extending more than 1 million light-years in diameter. To put that into perspective, light takes only 1 second to circle the Earth. To cross Andromeda's halo, light would need 1 million years. Why the halo matters, but what makes this halo so important? The answer lies in the unseen matter that fills it. More than 80% of Andromeda's halo is thought to be made of dark matter. We cannot see it, cannot touch it, but we know it's there. It pulls on stars. It bends light from galaxies beyond. It creates the skeleton that galaxies are built upon. Without dark matter, Andromeda would not hold its spiral arms together. Its stars would drift apart like sparks from a fire. In many ways, the halo is the galaxy's backbone, its silent guardian. And yet, the halo is also a graveyard. Hidden in its vastness are remnants of smaller galaxies that Andromeda has swallowed over billions of years. Their stars were torn apart and scattered into long streams, faint ribbons stretching through the darkness. Every one of these streams tells a story of cosmic violence, of collisions and mergers that shaped Andromeda into what it is today. So when we speak of the halo, we are not just talking about space. We are talking about history written, not in books, but in stars. A cosmic mirror here is where the mystery deepens, because our own Milky Way has a halo too. And just like Andromeda's, it is full of dark matter, ancient stars, and the echoes of devoured galaxies. And when scientists compared the two, they discovered something profound. The halos of Andromeda and the Milky Way are so large, they already overlap. This means that in a very real sense, our galaxies are already touching. The spirals we admire from afar have not yet met, but their halos, these ghostly crowns, are entwined. They pull on one another, weaving a dance that will one day bring the galaxies together. It is humbling to think that while human history stretches back only a few thousand years, this slow-motion encounter has been unfolding for billions. Every civilization that has ever looked at the night sky has unknowingly witnessed a cosmic story already in progress, the central mystery. And so we return to the core question. What exactly is Andromeda's halo? Is it just a shell of dark matter and forgotten stars? Or is it something even deeper, a map of how galaxies live and die, how they grow, and how they connect to the fabric of the universe itself? The truth is, we are only beginning to find out. Space telescopes like Hubble and instruments that measure ultraviolet light have started to map the halo, detecting its gas and structure. They reveal vast clouds of ionized gas stretching across half the sky. This gas is so hot, so thin, and so spread out that it would be invisible to our eyes, even if we could float inside it. And yet, this halo gas may be the very fuel that replenishes Andromeda's stars, ensuring that new generations of suns continue to form. So the halo is not only a relic of the past, it is also a reservoir of the future. It preserves memory, and it carries promise, a human connection. Chapter 2. Dark Matter's Shadow. When we think of galaxies, we imagine glowing spirals of stars, swirling arms filled with light, and bright cores where energy blazes. But in truth, those brilliant features are only a fraction of what a galaxy is. The real structure is invisible. Andromeda's halo, like our own Milky Way's halo, is built mostly from something we cannot see: dark matter. This phrase, dark matter, has become one of the most mysterious terms in modern science. It does not shine, it does not absorb light, and it does not interact with ordinary matter in ways we can touch or test directly. And yet, it makes up most of the matter in the universe. Without it, galaxies like Andromeda would simply not exist. The spiral arms would scatter into space. Stars would drift apart. Gravity alone, from the matter we can see, is not enough to hold them together. Something else must provide the hidden scaffolding. That something is dark matter, the skeleton of the galaxy. Astronomers discovered dark matter through its influence. When they measured how fast stars move within galaxies, the speeds made no sense. The outer stars should have flown away, just as planets would escape a star's pull if they orbited too fast. But instead, they stayed bound. The only explanation was that an unseen mass was pulling on them, far more mass than the stars and gas we could see. This was the first clue to dark matter. It told us that galaxies are not just islands of stars, they are surrounded, even defined, by halos of invisible material. Imagine a skeleton inside a body. The muscles and skin are what we seethe, the glowing arms of Andromeda, the bright stars of the Milky Way. But the skeleton is what holds everything in shape. Remove it, and the body collapses. The halo is the skeleton of a galaxy, and dark matter is the bone. In Andromeda's case, the dark matter halo stretches millions of light years. It outweighs the visible galaxy by a wide margin. The trillion stars we admire are only small decorations on a much larger structure, the silent embrace of two giants. Now here is where the story turns epic, because our Milky Way also has a dark matter halo, and these halos are so large, so extended, that they already overlap. We think of the collision between Andromeda and the Milky Way as something far away in time, 4 billion years from now, but in reality, the encounter has already begun. Not with the glowing disks we see in images, but with the halos, these invisible giants, stretching across the void. Picture the vast shadows, millions of light years wide, slowly reaching toward one another. Long before the spirals ever meet, their halos have touched. They pull at each other with quiet, unstoppable force. This is not a fast process. It is a dance that takes billions of years. But it is happening now, even as we live our brief human lives. And in that embrace lies our future, because these halos are not just passive shells, they are active. They exchange energy. They shift the orbits of smaller galaxies that orbit around both giants. They prepare the stage for the eventual merger of two great spirals into one colossal galaxy. Tools to see the invisible. How do we know this? How can we study something we cannot see? The answer is that we have learned to read the universe by its shadows and distortions. One of the most powerful tools is gravitational lensing. Dark matter has gravity, just like visible matter. When light from distant galaxies passes through a halo, the light bends, creating arcs and distortions. By studying these warped shapes, astronomers can map the invisible. It is like seeing ripples on the surface of a lake, and from them, learning the shape of the wind that moved across the water. Another tool is cosmic simulation. Supercomputers take the laws of physics and build entire universes inside their memory. They start with conditions similar to the early universe, then let gravity, matter, and energy evolve over billions of years. What emerges is astonishing. Galaxies form within massive halos of dark matter. Their stars trace spirals, their gas forms disks, but everything is scaffolded by halos. When simulations add dark matter, the galaxies look like the ones we see through telescopes. Without dark matter, the universe would look wrong, empty. Together, lensing and simulations confirm the idea. Halos are real, and they are fundamental. A battlefield of shadows, but the story does not end there. Because the halo is not a calm place, it is a battlefield. Inside Andromeda's halo, streams of stars reveal where smaller galaxies were torn apart. Each stream is evidence of a past collision, a scar across the invisible body of the halo. Gas clouds drift, heated by shock waves from violent events. Dark matter clumps together, then stretches apart, shaping how new stars will form in the future. When Andromeda's halo collides more fully with the Milky Way's halo, this battlefield will expand. The halos will not simply blend, they will clash, overlap, and redistribute their dark matter. The smaller galaxies caught in between dwarfs, orbiting both giants, may be thrown into new orbits or consumed entirely. It is war, but a silent one. No explosions we can hear. No sound at all, just gravity, the great sculptor, reshaping the cosmos over unimaginable spans of time. The human scale, and here is where the story bends back to us. We live on a small planet circling an average star, and yet we are already participants in this epic struggle. Our galaxy's fate is sealed by the pull of Andromeda's halo. Even if no star ever collides with another, even if Earth survives the merger untouched, the identity of the Milky Way will vanish. We will become part of a new creation, sometimes called Andromeda, a vast elliptical galaxy born from two spirals colliding. For now, the halos fight in silence, while we live out our short human centuries. But through our instruments, our science, and our imagination, we can witness their battle. We can see what otherwise would remain hidden forever. Chapter 3. The Hidden Archive of Ancient Stars. Every galaxy has scars. They are not carved in stone or written on parchment, they are written in stars. And nowhere is this more true than in the vast halo of Andromeda. If you look closely at this faint outer region, you will notice strange patterned streams of stars stretching across the sky like cosmic rivers. They are not random. They are the remnants of galaxies that Andromeda once consumed. Every faint star in the halo is a survivor, a witness of cosmic cannibalism. The predator behind the beauty. We often describe Andromeda as beautiful. A spiral galaxy glowing with 1 trillion suns, shining 2 million light-years away. But behind that beauty is something far more ruthless. For billions of years, Andromeda has fed on its neighbors. Small galaxies wandered too close, and its gravity pulled them apart. Their stars were scattered, forming long trails that now thread through the halo. Andromeda is not just a galaxy, it is a predator. And its halo is the evidence of every meal it has ever taken. This is not just poetic language. Astronomers have mapped these streams in great detail. Some are so faint they took decades to confirm. Others are brighter, forming loops and arcs that wrap around the galaxy like ribbons. Each one tells a story. a dwarf galaxy torn apart, a star cluster stretched into threads, an ancient companion reduced to memory. The streams as testimony. One of the most famous examples is the giant stellar stream. It arcs more than 300,000 light-years through Andromeda's halo, a massive trail of stars left behind by a galaxy that once dared to drift too close. Today, the original galaxy is gone, but its stars remain, orbiting in a broken loop, silent witnesses to the violence that destroyed their home. There are many others. Ultra-faint dwarf galaxies, tiny companions with only a few thousand stars, have been discovered around Andromeda. Some half-digested, their structures distorted by gravity. Star clusters that once held tightly together are now stretched like melted wax, strung out into lines of light. Each of these remnants is not just debris. They are archives. They record Andromeda's past, the timeline of every collision, every conquest. By studying them, scientists can reconstruct the story of how the galaxy grew, piece by piece, devouring smaller neighbors. A library written in light. Think of Andromeda's halo as a library. Each stellar stream is a chapter. Each faint cluster is a page. Together, they form a record of cosmic history stretching back billions of years. Unlike human libraries, these archives are not made of words, but of orbits and trajectories. Astronomers act as historians, reading the positions of stars like sentences. By modeling their movements, they can work backward in time, revealing when and how the collisions occurred. This library shows that Andromeda has been anything but quiet. While its spiral arms may appear calm from a distance, its halo tells the truth. Andromeda has spent its lifetime in conflict, growing stronger by consuming others. Human reflections. It is tempting to think of galaxies as eternal, peaceful ornaments in the night sky. But the reality is more complex, and in a way, more human. Just as civilizations on Earth have risen and fallen, merging and conquering, so too do galaxies. Andromeda is not static, it is a product of survival and change. When we look at the halo, we are not looking at a distant curiosity. We are looking at a mirror. Human history has been shaped by conflict, by empires that consumed their neighbors, by cultures that absorbed others into their identity. Andromeda is no different. It too has shaped its destiny through struggle. This comparison is not meant to diminish the galaxy, but to bring it closer to us. In the cosmic scale, Andromeda is vast beyond comprehension, but in its patterns of growth, it is strangely familiar. It reminds us that even in the stars, survival is rarely gentle. Modern discoveries. The discoveries of the past 2 decades have transformed our view of Andromeda's halo. Surveys with wide-field telescopes have revealed dozens of stellar streams, faint dwarf galaxies, and ultra-diffuse structures. Some are so fragile that only a few stars mark their existence. Others stretch across enormous distances, showing how thoroughly Andromeda has shaped its surroundings. Astronomers now believe that at least half of Andromeda's halo stars came from other galaxies. This means that what we call Andromeda is not a single entity. It is a collection, a mosaic built from the remains of many smaller systems. One striking discovery is that some of the streams orbit in a coordinated way, as if they were once part of a larger structural group of galaxies that fell into Andromeda together. This suggests that the cannibalism was not random, but organized in waves, like invasions in human history. The epic perspective, when narrated on a grand scale, this story feels almost mythic. Imagine Andromeda as a titan in the night, surrounded by its trophies, the scattered bones of the galaxies it has devoured. These trophies do not fade. They orbit forever, whispering the truth of what happened. The halo, then, is not just a structure. It is memory itself. Every faint star is a witness. Every stream is a scar. Together, they remind us that creation and destruction are not opposites in the cosmos. They are the same process. Galaxies grow by consuming. They become what they are by erasing what came before. And yet, out of this violence comes beauty. Without these collisions, Andromeda would not shine as it does. Its spiral arms would not be so rich. Its stars would not be so numerous. Destruction and creation are bound together, inseparable, toward our future. Why does this matter to us? Because the Milky Way has its own halo, its own streams and scars. Our galaxy too has consumed its neighbors. We are not separate from this process, we are part of it. And soon, we will be part of Andromeda's story. When the two galaxies merge, their halos will bring with them all the evidence of past battles. Streams from Andromeda and the Milky Way will mix, overlapping histories blending into one. The library will not close. It will expand, creating new chapters for the next observers. For the next observers, whoever they may be, billions of years in the future. Chapter 4. Collision Course. Halos in combat before the spirals embrace. Their halos clash in silence. This is the part of the story most people never hear. We often imagine the future collision between the Milky Way and Andromeda as two bright disks crashing together billions of years from now. But the truth is, the collision has already begun. The first blows are invisible. The halos of both galaxies vast, diffuse cocoons of dark matter, and scattered stars are reaching across 2 million light-years, touching, blending, and exchanging energy right now. The silent war has begun. If you could step outside the boundaries of our galaxy and look back, you would see a giant sphere surrounding the Milky Way. That is our halo. It stretches hundreds of thousands of light-years in every direction, filled mostly with dark matter and unseen scaffolding that holds the galaxy together. Andromeda has a similar halo, even larger. These halos are not empty. They are massive, weighing more than the luminous stars and gas of the galaxies they encase. They are the hidden giants of the universe, and as Andromeda drifts closer, these halos overlap. Long before the bright spirals merge, the halos are already locked in combat. This war is silent. There are no explosions, no flashes of light. Instead, it is a slow tug-of-war, gravity pulling at gravity, invisible particles of dark matter brushing against each other like ghosts. To us, it looks like nothing, but in truth, it is the opening act of one of the greatest events in cosmic history. Epic forces at play. Imagine two titans standing across a battlefield. Their arms stretch far beyond their bodies, touching and grappling long before their torsos meet. That is what is happening now between the Milky Way and Andromeda. Dark matter, though invisible, is not passive. It bends space itself, shaping how stars move and how galaxies form. As halos interact, they exchange momentum. They slow each other down. They pull on each other's stars, sending faint ripples through the cosmic fabric. To us, these effects are hard to see, but with the tools of modern science, we can trace their fingerprints. Gravitational lensing, the bending of light by unseen mass, reveals the true shape of halos. Computer simulations show how halos merge long before galaxies collide. The evidence is clear. The encounter is underway. The countdown to merge is so. When will the great collision happen? Astronomers have charted the course. In roughly 4 to 5 billion years, Andromeda and the Milky Way will fully merge. At first, they will pass through each other, tearing at each other's stars. Then they will circle, collide again, and finally fuse into a single giant galaxy, an elliptical titan, sometimes called Milky Way. From Earth's perspective, the night sky will change. Over millions of years, Andromeda will swell larger and larger until it dominates the heavens. One day, its spiral arms will stretch across the entire dome of the sky, brighter than the Milky Way itself. It will be the most spectacular sight any human or any descendant of humanity will ever see. What happens to Earth? This question always arises. What will happen to our solar system when the galaxies merge? The answer is both reassuring and unsettling. The chance of our sun colliding directly with another star is extremely small. Stars are far apart, and even in a collision of galaxies, they usually slide past one another. But the gravitational chaos will not spare us entirely. Our solar system could be flung into a new orbit, drifting farther from the galactic center or closer. We might find ourselves in the outer reaches of the new galaxy, or swept into a different spiral arm. In extreme cases, We could even be ejected into intergalactic space, a lone wanderer carrying the history of Earth into the dark between galaxies. By that time, however, Earth itself may no longer be habitable. In 5 billion years, our sun will be near the end of its life, swelling into a red giant and burning away its planets. Humanity, if it survives, will not be on Earth. Our species, or whatever we evolve into, will have long since left home. Humanity's place in the collision. Here the story turns speculative, almost philosophical. If humans endure, what role will we play in this collision? One vision is bleak. By the time the galaxies merge, humanity may be gone. Another extinct chapter in the story of life. The collision will occur without witnesses, a cosmic drama unfolding to an empty audience. But another vision is more hopeful. Perhaps by then, we will have become interstellar travelers, spreading across the galaxy, watching the approach of Andromeda with awe. Imagine civilizations thousands of light years apart, all looking up at the same sky, all seeing Andromeda draw closer, sharing a collective memory of a cosmic dawn. By then, technology could allow us to cross between stars, to harness energies beyond our imagination. We might not just witness the merger, we might thrive within it, adapting to new orbits, exploring the new worlds created by gravitational chaos. In this vision, the collision is not an end, but a beginning, building suspense. The halos as battlefields. The key to understanding this event lies in the halos. They are not passive shells. They are active battlefields, shaping the outcome of the merger before it happens. Their gravitational pull determines how fast the galaxies close in, how stars are redistributed, and how the final galaxy will look. Think of them as invisible armies clashing long before the generals meet. Every dark matter particle, every faint star in the halo, plays a role in the outcome. These are not silent spectators, they are participants in a slow, inevitable dance that will last billions of years. This battle is unlike any war we know. There are no victors, no losers, only transformation. Out of chaos will come order, a new galaxy, larger and brighter, forged from two giants. The epic tone of destiny, the collision of the Milky Way and Andromeda, is not just an astronomical event. It is destiny written in the fabric of the universe. Gravity leaves no choice. From the moment these galaxies formed, their paths were set. Across billions of years, through the rise and fall of stars, through the birth of life on Earth, the outcome was always the same. They would meet. There is something deeply moving in this inevitability. Our lives are fleeting compared to cosmic time, but to know that we are part of a story billions of years long gives us perspective. The same force that binds us to Earth, that keeps the moon in orbit, is the force pulling Andromeda toward us. Gravity connects everything. We are not bystanders, we are inside the story. Chapter 5: Humanity's Cosmic Reflection. When we began this journey, we set out to study a faint, invisible structure, the halo of the Andromeda galaxy. On the surface, it may seem like a technical detail, a forgotten border of starlight and dark matter. But the deeper we looked, the more profound the questions became. Because halos are not just astrophysical curiosities, they are cosmic teachers. They reveal truths about the universe that challenge our senses, reshape our understanding, and force us to reflect on our place within the grand story of existence. Lesson 1. Most of the universe is invisible when we gaze at the night sky. We think we see the universe. Stars glimmer like jewels. Galaxies float like islands of light. Nebulae glow softly, colored by gas and dust. But the truth is staggering. What we see is only a sliver of what exists. The visible stars, planets, and galaxies, the things our eyes and telescopes can capture, make up less than 5% of the cosmos. The rest is hidden, cloaked in shadows. Dark matter and dark energy shape everything, yet remain unseen. Halos remind us of this fact. They are immense, far larger than the bright disks of galaxies, and yet they are invisible to the human eye. We know them only through their influence, how they bend light, how they guide stars, how they determine the fate of galaxies. In studying halos, we are reminded that reality is not limited to what we can see. The universe is built on hidden scaffolding, and so is our own existence. Lesson 2. Destinies are entangled. The halo also teaches us another truth. The fate of galaxies is tied together long before they meet. When we look at the Milky Way and Andromeda, they appear as separate giants, drifting in the void. But their halos overlap. Their dark matter has already begun to mix. Their fates are locked, not in the future, but in the present. This is a humbling idea. It shows that what we call independence is often an illusion. Just as galaxies are bound by gravity, so too are we bound by history, by relationships, by the invisible forces that connect us. Our lives may feel isolated, but in truth, they are woven into larger patterns that stretch far beyond what we see. The universe itself reminds us, nothing exists alone. Humanity's mirror. When we shift from astronomy to reflection, the halo becomes a mirror. It shows us that what matters most is often hidden. The unseen currents of gravity determine the shape of galaxies. The unseen choices of individuals and cultures determine the shape of history. We are not separate from the cosmos. We are part of it. Every atom in our bodies was forged in ancient stars, scattered by explosions, gathered into clouds, and assembled into life. We are the product of invisible processes, billions of years in the making. And when we study Andromeda's halo, we are not just looking outward, we are glimpsing the hidden architecture of our own future. For just as halos are already colliding, so too is our galaxy's destiny entwined with Andromeda's. We are participants in a cosmic story far larger than ourselves. The epic perspective. There is something deeply moving in this realization. For most of human history, we thought of ourselves as small, fragile beings under a vast, indifferent sky. But modern astronomy has revealed something richer. Yes, the universe is vast beyond comprehension. Yes, our lives are brief compared to cosmic time. But the same laws of gravity that guide galaxies also hold us to Earth. The same forces that sculpt halos also sculpt our future. The story of the universe is not happening around us, it is happening through us. When Andromeda's halo presses against our own, it is not an abstract fact, it is our reality. It is a reminder that we live inside a process billions of years long, and we have the rare gift of awareness. We can see it, we can understand it, we can tell its story. That awareness itself is epic. Out of countless stars and galaxies, in a universe mostly invisible, consciousness has emerged here, on this small planet, at this small moment, and with it comes the power to reflect, to ask, to wonder. The fragile role of witness. Perhaps humanity will not survive long enough to see the full collision. Perhaps Earth will fade under the heat of a dying sun. But even if we are gone, our awareness now matters. Because in this fleeting moment, we are witnesses. We are telling the story of the halos before they merge, of galaxies before they unite. This is not a small thing. In a universe where most is unseen, to see it all is extraordinary. To record, to imagine, to share, these are acts of survival too, just on a different scale. And perhaps, just perhaps, our descendants will endure. If they do, they may watch the sky brighten with Andromeda's arms. And they will remember that we once looked forward to that day. They will know that we saw it coming, and we tried to understand. A universe written in shadows, and so we arrive at the final lesson of the halo. It is a reminder that our universe is written in shadows. What we see is only the surface. The true architecture is hidden, waiting for us to uncover it. This is true of galaxies. It is true of life. It is true of humanity's future. To understand the shadows is to understand the whole. To explore the unseen is to discover where we came from and where we are going. The halos of galaxies are not empty. They are archives of history, battlefields of destiny, blueprints of the future. They are the unseen stage on which the next act of the cosmos will unfold. And so, as we leave Andromeda's halo behind, let us carry its message with us, that most of reality lies beyond sight, that destinies are bound together long before we realize it, that our story is part of something far larger than ourselves. In studying the halo, we are not just looking outward, we are looking inward. We are glimpsing the hidden framework of the universe, and in it, a reflection of our own fragile existence. The halo is a reminder. Our universe is written in shadows. To understand them is to understand where we came from, and where we are going. If you want to keep journeying into the hidden layers of the universe with us, don't forget to like, subscribe, and share your thoughts in the comments. The cosmos is vast, but here, we explore it together.